Welcome back, students. So in this video we'll be doing question number 3. So this is given, okay, we have to prove that the following are irrational. So we have to first prove, we'll go for the first question 1 by root 2, okay? Clear? So we have to prove if this is, it's an irrational. So let us just say, we'll be doing this just the way we have done the previous question. So I'll say let 1 by root 2 be rational. Okay, so if it's a rational, that means 1 by root 2 is actually in the form of a by b, where both a and b are integers, right? That is the definition of a rational number, right? Okay, so we're going to assume this. Alright, so after this, let me take this to the left hand side. So b by root 2 equal to a. Okay, next I'll take root 2 to the other side, so root 2a, and then I'm finally left with b by a equal to root 2. Okay, so what do we understand by this? We know, okay, that b by a are both integers. So obviously b by a is going to be integer. So here b by a are both rationals, right? Let's do it. Okay, we got b by a, so b by a is a rational number because both a and b are integers, right? So, and we also know, and if you go back, b by a is equal to root 2. So in the sense, if b by a is a rational number, so we have shown that this is a rational number, right? We have already proved this is a rational number. So since b by a is equal to root 2, then that means root 2 is also rational, is also a rational number. But this is a contradiction, right? This is a contradiction, as root 2 is not a rational number. Okay? It's not a rational number. Either way, if you're not very convinced, remember, rational number must be in the form of p by q, where both p and q must belong to an integer. So in the case of root 2, even if it's not written, we understand that the denominator is always going to be 1. Q, okay, so this is going to be p and q. Q is 1, which is definitely an integer, checked, but is root 2 an integer? Root 2 is not an integer, okay? Okay, therefore, what we say that our assumption is wrong. Okay, our assumption is wrong. So what was our assumption that we took? We took the assumption that let 1 by root 2 be rational. Now since this assumption is wrong, we can simply conclude that 1 by root 2 is irrational. Okay, alright, so we're done with the first question, and we'll go with the second question as well. Okay, so the second question that is given is, we have to show that 7 root 5 is irrational. So again, the same proof the way we have done. Okay, we'll say let 7 root 5 be rational. It's the same way we have done. Let it be a rational. So if it's rational, 7 root 5 is going to be equal to a by b. Again, you can always write in bracket a by b. This symbol actually means belongs to. Okay, belongs to an integer. Okay, that means it is an integer in the sense. Now let's make some changes. So I'm going to keep root 5 as it is, and I'm going to bring 7b over here. Now you look at this, a by b, a by 7b, and we're both a and b are both integers. Okay, a and b are both integers. So that means a by 7b is an integer, is a rational number. Okay, it is a rational number. Alright, let me tell you why. Okay, I'm not sure, maybe some of you are still confused. See, a and b belongs to z means a can take any one of the values. A and b can take any one of the values. It can take 0, plus minus 1, plus minus 2, plus minus 3. It can take any integers. It should only be integers. It cannot take any other value. Okay, in a sense, it will take only integers. That's what we mean. A, b belongs to z. Okay. You can take any integers, alright? So a and b, you can put any values you want. You can put 0 if you want, you can put plus 1 if you want, or minus 1 if you want, okay? Simultaneously. So if you suppose you put your a as 0 and your b as 7 into 1, okay? You take your a as 0, which is also an integer, right? 0 is an integer, check. And b1 is an integer, so we're correct, okay? So we're going to get 0 by 7. Now this is also going to be a rational number, right? Because 0 is an integer, whereas 7 is also an integer, okay? So by this, you keep on substituting any values that you want for a and b, okay? You put 1, 2, 3, 4, 5, 6, minus 1, minus 2, whatever numbers you want, you can just put as long as it's integer. A by 7b is going to be a rational number. Now since a by b is a rational number, this is a rational number, okay, rational number, then that means, so root 5 must also be rational, right? Must be rational. You look at this, these are both, they are equal. A by 7b is equal to root 5. So that means if a by 7b is a rational number, obviously root 5 also has to be a rational number. But this is not possible. But this is not possible, right? This is not possible. But this is not possible. Yes, as root 5 is an irrational number. Okay, irrational number. Alright. Hence, our assumption is wrong. Okay, our assumption is wrong. Therefore, 7 root 5 is irrational. Okay, and you can always add an a to it, hence proved. Okay, so our assumption is wrong, and our assumption was we let 7 root 5, we assumed it to be irrational, but since that assumption is wrong, definitely it must be irrational. Okay, so we'll go with the last question for this, question number 3. So for the third question, we have this 6 plus root 2. So I'm going to say let, okay, let us assume 6 plus root 2 is rational. So if 6 plus root 2 is rational, then it's going to be equal to a by b, right? So we'll make the necessary changes. So a by b, I'm taking 6 to the right hand side, so it will become minus 6. You can make necessary changes. You take common here, b, so a minus 6b. Okay, now you look at this, a minus 6b by b. Remember here a and b are integers, okay? So a and b can take what? Any value, 0 plus 1 plus minus 2, alright? Does not mean if a is 0, b must be 0. It's not like that, okay? You can put any values you want as long as it's an integer. You can put a 1. If you want, you can put b as minus 100 also, no problem. You must just check that is 1 an integer, is okay? Or is minus 100 an integer, alright? Clear? And integers go up to infinity, okay? Plus minus 1000 is also an integer. Clear? You get it, right? So you can just keep on substituting here, okay? So obviously, if you substitute here, you just keep any values of a you want and put any values of b you want. You'll get both numbers, okay? It will be a number, and this will both be an integer. So therefore, a minus 6b by b is a rational number, okay? It's a rational number, alright? So since this a minus 6b by b is a rational number, that means root 2 must also be a rational number because they are equal, yeah? Hence, root 2 must also be a rational number, must also be a rational number. But this is, you can write this is not possible or this is a contradiction or anything you want, okay? You can form the sentence that you want, but this is a contradiction as root 2 is irrational, okay? It's irrational. So, therefore, our assumption is wrong, okay? Our assumption is wrong. Hence, 6 plus root 2 is irrational, okay? Our assumption is wrong, so we just have to show that 6 plus root 2 is irrational. Okay, so you can always add it with hence proved. Okay, so this is it. We shall end the video here.